4i adding vectors examples. Let's add two vectors using the three methods. The first vector will be v1, 67.0 meters per second, 45 degrees north of east. We will draw this in red so you can keep track of it. Let's make sure it's drawn to scale and pointed in the right direction. First off, to make the measurements a little easier, we will add a set of crosshairs at the base. As you can see with the compass, the vector enters into the first quadrant, and we'll have the direction that is north of east or east of north, depending from which axis we measure the angle from. Let's get a protractor in and measure the angle it makes. Now slide the protractor to the crosshairs. As you can see, it does make a 45-degree angle north of east. Now let's slide a ruler in and measure the length. As you can see, it seems to be 67 millimeters, which translates to 67 meters per second. Let's look at our second vector. It's v2, equal to 35.0 meters per second, 62 degrees east of south. We'll make this one blue. Put some crosshairs in. This one points into the third quadrant, which means it would be west of south or south of west. And using our protractor, it looks like it is 62 degrees west of south. Bring in a ruler, and it looks to be 35 millimeters, which converts to 35 meters per second. Let's look at our first method, the scale diagram method. This method requires drawing the vectors joined tip to tail, one after the other. Which comes first really doesn't matter, as the final measurement will always be the same. Here's vector 1 in red, and here's vector 2 in blue. Let's draw a crosshair and have the red begin from the center of it. Now let's add the blue vector. We'll line up its tail to the red's tip. Now if we add a line where red started and where blue ended, we have the resultant vector line. In this case, the resultant velocity, which we would denote as v subscript r. Let's remove the red and the blue vectors and focus on the resultant vector. We will use a ruler to figure out how long it is. It looks like it's 36 millimeters, which translates to 36 meters per second. And bring in a protractor to measure the angle. It looks roughly 63 degrees north of east. The second method is called the tip-to-tail method. It will use a triangle that you would have drawn for the scale drawing, but uses trigonometry to solve for the length and the angle. Often you will need to use the sine and cosine laws, so review those if you find those challenging. So begin with the scale diagram that you drew from the last example. We know that vector 1, red, is 67 meters per second, and vector 2, blue, is 35 meters per second. We also know that vector 1 is 45 degrees north of east, which makes the top angle also 45 degrees due to the alternate interior angles are equal rule, better known as the Z law. Because this black angle is square, or 90 degrees, then this angle is also 45 degrees. The blue angle is 62 degrees west of south. 62 minus 45 makes the angle between the red and the blue lines 17 degrees. Now we have a triangle that has two sides and one angle with measurements. We will try to use the sine and cosine laws to solve the purple resultant's length and the angle. Let's label the vertices and the sides. Using the cosine law, we find the measure of the resultant, b, is 35.06 meters per second. And using the sine law, we find the angle between the red and purple, angle A, to be 17 degrees. To calculate the angle north of east, we add the 45 and the 17 degrees to find the angle of 62.0 degrees north of east. Our final measure for the velocity resultant is 35.0 meters per second, 62 degrees north of east. The third method is the component method. This method breaks up a vector into its two base components, the horizontal component, also known as the x component, and the vertical component, also known as the y component. For example, vector 1, the red vector. If we draw a horizontal and vertical line joining the tail to its tip, we can see that this vector is composed of two components. Because the triangle that we created by drawing these two lines is square, we know that the angle at the tail is 45 degrees, making the other one 45 degrees as well, based on the sum of angles in a triangle having a sum of 180 degree rule. We can now use trigonometry to calculate x and y components. Now note the vector points up and to the right, into quadrant 1, which makes the x a positive value and the y a positive value. I used the cosine ratio and found y1 to be 47.38 meters per second, and used the sine ratio to find x1 to be 47.38 meters per second as well. For the second vector, the blue vector, we have the same scenario, creating a right triangle. But note that the vector points down and to the left into quadrant 3, which makes x negative and y negative as well. Now remember, this is a right angle triangle. The top angle is 62 degrees west of south, making the bottom angle 28 degrees, as all three have to add up to 180 degrees. We will now use the trig ratios to calculate the x and y components. I calculate y2 to be negative 16.43, and I calculate x2 to be negative 30.90. Now if we add up the x's and add up the y's, we get our resultant vector VR. The x resultant equals x1 plus x2, and the y resultant equals y1 plus y2. The x resultant is 47.38 plus minus 30.90, which makes 16.48 meters per second. The y resultant equals 47.38 plus minus 16.43, making the resultant 30.95 meters per second. Now we will create a resultant vector by drawing in xr and yr. We will use a ruler and draw in x resultant at 16.43 millimeters, which represents 16.43 meters per second. It's positive, so we'll draw it to the right. We'll also use a ruler to draw the y resultant at 30.95 millimeters, representing 30.95 meters per second. It is also positive, so we'll draw it upwards. If we draw a line joining the tail of one to the tip of the other, we end up with our resultant vector, VR. The result is a right angle triangle, where the x-axis is 16.48 meters per second, and the vertical axis is 30.95 meters per second. We can solve for the vector resultant by simply using Pythagorean's theorem. The resultant vector equals 35.06 meters per second. To solve for the angle, we can use any of the three trig ratios since we know all three sides. I calculate the angle to be 62.0 degrees. Now, again referring back to our compass, we see that it is north of east. Our final answer is velocity resultant is 35.06 meters per second, 62 degrees north of east.